Hello students, today we're just going to compare homework. We're going to be graphing exponential functions or exponential growth to be more specific. And students will be able to sketch a graph from a scenario, a table, or an equation. And so let's start with our first scenario or the scenario part. A worker in the cafeteria didn't wash his hands. He left 200 E. coli bacteria on his hands. They double every 30 minutes. Graph this. So you can do it directly. You can do a table if you want, but we're just gonna learn how to do it directly right now. When I say draw a graph, in reality, it's gonna be a sketch because it's not gonna be very specific. But what we need to know is that the cycles are every 30 minutes. And so it's going to be 0, 30, 60, 90, 120, etc., etc. And we start with 200 E. coli as the initial point. If you want, you can even write the function just like in the previous lesson, but right now it's just focusing on drawing the graph, okay? Or sketching actually. So we start at 200, and I'm gonna start very small just because exponential functions grow very fast. So we start with 200, that's the initial point. The cycle is every 30 minutes, that's why it's important that we write in here how often does this happen. And it says that E. coli doubles every 30 minutes. So double, if this is 200, then it's gonna double, that means that at 400, which is about right there. Then that doubles, right? It's not gonna be 400, but rather at 800. Notice how I'm measuring, and it's not accurate, but it's an estimate of where it would be. So after 60 minutes, it's gonna be at 800. And then another 30 minutes, another 30 minutes go by, it doubles once again. Okay, so about right here. And so my point at 90 minutes is gonna be there. And then it doubles, but if you notice, it's gonna go like around here. I don't know if you want to put it over the words, but that's how it would go. Okay, and then I just connect my points. So in here it will go like that. Okay, and again I can just kind of like go, but it will be over my word problem. This E. coli means that also in the past it could have started, right? And it's just gonna converge onto 0. Okay, so it will be something like that. Again, this is a sketch because it's not exact, but that's what it means. It doubles. Notice how I'm doubling, not accurately, but approximately doubling every cycle. Now let's see. That's graphing from a scenario. Sometimes they're going to give us a table. Let's say that this table represents spam email. And it says, oh, you know, somebody sends 7 emails. They're asking each one to send it to 5 people. Okay, so if you notice what is happening here, you're multiplying by 5. You're multiplying by 5. 5 multiplying by 5. Okay, so it's growing by 5. How would my graph look for this one? And again, you can try the function. You can try writing the function, remember the initial point, the base, and then the cycle. The cycle is every one, let's say that this happens every 1 day or every week. It doesn't matter. I mean, you see 1, but it doesn't specify if it's per week or per year or per month, but it's every 1. So it's going to be 0, 1, 2, 3, 4, 5. And we start with 7. Again, we're going to start very small, and I hope you can see it. Oh no, sorry. So the cycle will be 0, 1, 2, 3, 4, 5, etc., etc. And again, for the initial point, it's 7, so that's my first point. And then what happens after every cycle? Well, it goes up by 5. We multiply by 5. So let's think. If this is 7, 5 times 7 will be 1, 2, 3, 4, 5 times. So it will be about here, the 35. Okay, so after 1 week, let's say, we have 35 spam emails. And then 5 times 35, so it's going to be 1, 2, 3, 4, 5, about here. So if you notice, we're not even going to have more than 3 points in here, and very difficult to see because this is even hard to input in there. Okay, so basically my graph would start at 7, and then I just connect the points, and this will be my sketch. Remember, if we go in the back in the past, then it would converge onto 0. Okay, converge onto 0. So that's how it would grow. My initial point times 5 times 5, and that's it. Now what if they're giving me the function? So in here I have 3 different functions, and I'm gonna show you on the same graph so that you can see the difference between these 3 and the similarities, because all 3 of them have the same initial point. They have the same base, meaning that they double, but the thing is that they don't double at the same time. In here it's for every one, let's say for every 1 hour. In here is every 3 hours. And in here is every 1/3 of an hour, which is basically every 20 minutes, right? Or that it happens 3 times in 1 hour. Okay, so let's see. Let's see how this looks. I have 0, 1, 2, 3, 4, 5, and 6. And then my initial point is 6. So let's say that I'm going to put my 6 in here. Again, tiny, so that we have plenty of space to see how many points we can draw. And so for the first one, it says f of t. T is just another, again, you can change this variable, but some of them will use t for time. Okay, so f of t, the initial point is 6, and then that doubles every hour. Okay, for every hour it doubles. That's what it means in there. So I'm gonna use this aqua color for this first function. So my initial point after 1 hour, it's gonna be at 12. After 1 hour, it's gonna be at 12. Another hour passes by, and then it doubles again. So 24. And I'm just gonna draw the next one, which is 48, about here. Okay, so 12, 2 hours later, 24, 3 hours later, we're gonna have 48. Okay, again, this is a sketch of what happens after, like, every hour. And again, it can be in the past as well, like what happened 1 hour ago. 1 hour ago, 2 hours ago, etc. And it will converge towards 0. Now, what if we do this one for every 3 hours? It doubles every 3 hours. My initial point, which is at 6, and then 3 hours will go by, and then it doubles. So it's not 6 anymore, it's now at 12. But notice how it's after the cycle is 3 hours, so after 3 hours it doubles. Another 3 hours, and then it doubles. And you can guess that again, another 3 hours. Oops, let me do one more. After 9 hours, and that's gonna double. Okay, so that's how the sketch of my graph will look. And to the back also, instead of being here, it's gonna be around 3 hours. So that's how it would look. It will also converge towards 0, but it's gonna take longer to converge. okay? To get closer to 0, I mean. For the next one, I'm gonna use this blue. And so what is happening? It doubles every 1/3 of an hour, meaning every 20 minutes. So we start with the same initial point, but after 20 minutes, it's gonna double. And another 20 minutes, and it will double. And another 20 minutes, meaning already the hour, is gonna double. So that's how my graphs coming from different functions in the same relationship would look, okay? For every hour, every 3 hours, you notice that the points are more or less aligned, but it happens at different cycles, right? The cycle is different. Okay, so that's what we're going to be doing today. You're going to be graphing or sketching graphs from scenarios, from a table, or from given the function. Okay, so have fun. Thank you. Bye-bye.